Okay, this is my second reassessment on forces and circular motion. And the problem reads, a 12 kilogram ball is attached to a 1.2 meter string that can withstand a maximum of 230 newtons of tension before it will break. As the ball is swung around in a horizontal circle, find the ball speed and the angle of the string relative to horizontal just before the string would break. Alright, so I start off my little body diagram right here, and you got the ball right here that weighs 12 kilogram. You're obviously going to have your force tension exerting upward in this direction with 230 newtons. You have your gravity pull, and you'd have your formula to find your, this is supposed to be negative. It's supposed to have your down gravity pull, and you have 12, which is the ball times the given acceleration, which we know is negative 9.8, and that gives us 117.6 newtons of pull. All right, and we end up getting our triangle here with Pythagorean theorem, which we end up getting our answer here for distance, which would be 1.2 meters with our x and y, Pythagorean theorem. We have our x and y components, which is 197.7 newtons on the x-axis, and on the y-axis we get right here, which is going to be positive going this way, 117.6 newtons. Okay, now we get our distance right here, which is going to be cosine 30.6 equals the radius divided by 1.2. And we can figure out to get the radius right there, 1.03. And of course we have our last formula to find our ball speed, which is going to be Fc equals mass times acceleration. And you have the ball, v squared, divided by the radius, and we get our x-axis 197.7, and we do our algebraic math, and that gives us v equals 4.12 meters per second. So this, going back to the problem, this problem says find the ball speed and the angle of the string. We have our angle right here, 30.6, and our ball speed, which is going to be v equals 4.12 meters per second. And this is my second reassessment on forces and circular motion.